In this question, he is saying that the least positive integer n such that the value of this is a positive integer. For doing this question, you should remember a concept that 1 plus I to the power 2 is simply 2i, and 1 minus I to the power 2 is minus 2i. You must remember this concept. It is very useful concept. Hence the given question can be written as 2 to the power n into I to the power n upon 1 minus I whole square whole to the power n minus 2 by 2. That is 2 to the power n into I to the power n upon minus 2i to the power n minus 2 by 2. That is 2 to the power n into I to the power n plus 2 by 2 upon minus 2 to the power by 2. Obviously, we will try for n equal to 2, 4, 6, etc. For n equal to 2, the answer is actually negative integer. For n equal to 4, the answer will be purely imaginary number. For n equal to 6, it is clear that the answer will be a positive integer, because for n equal to 6, we will get 2 to the power 6 into I to the power 4 upon minus 2 to the power 2, because now it is easy to see that the answer is 2 to the power 4. Hence for n equal to 6, answer is a positive integer. Therefore the least value of n is 6. In this question, it is given that if the real part of the complex number this, where theta belongs to 0 to pi by 2, is 0, then the value of this is equal to. Clearly, to find the real part of this, first I multiply divide by conjugate of this, that is z can be written as 3 plus 2i cos theta upon 1 minus 3i cos theta into 1 plus 3i cos theta upon 1 plus 3i cos theta. Clearly, the real part of this will be 3 minus 6 cos square theta upon 1 plus 9 cos theta. We put it equal to 0. That is, I get cos theta equal to 3 by 6. That is 1 by root 2, because it is given that theta lies between 0 and pi by 2. That is, I can say theta equal to pi by 4. Hence the value of sin square 3 theta plus cos theta is equal to 1 by root 2 square plus 1 by root 2 square, that is 1. In this question, it is given that let a complex number z satisfy this inequation, then the largest value of mod z is equal to. Before I do this question, I would like you to note this formula, that log of a to the base b less than c implies that a is less than b to the power c, but this formula is valid only if b is greater than 1. That is, the sign of inequality will remain same if base is more than 1, and log of a to the base b less than c implies that a is greater than b to the power c, if base lies between 0 and 1. If base lies between 0 and 1, sign of inequality will change. If base is greater than 1, sign of inequality will remain same. This thing I am going to use in this question. Now, keeping that formula in mind, this can be written as mod z plus 11 upon mod z minus 1 whole square greater than equal to 1 by root 2 to the power 2. That is, I get mod z plus 11 into 2 is greater than equal to mod z minus 1 whole square. That is, I get mod z square minus 4 into mod z minus 21 less than or equal to 0. And this means mod z minus 7 into mod z plus 3 less than or equal to 0. And this is obviously a positive number. Hence, this means mod z minus 7 is less than or equal to 0. That is, mod z is less than equal to 7. Hence, I can say greatest value of mod z is 7. Therefore, B becomes the correct choice. In this question, it is told to us that let Z and W be two complex numbers such that W is equal to ZZ bar minus 2Z plus 2I and mod of Z plus I upon Z minus 3I is equal to 1 and real part of W has minimum value. Then the minimum value of N for which W to the power N is real, where N is a natural number. Note that W has to satisfy two conditions. W should be equal to this also, and real part of W should be having minimum value also. First of all, we try to find the value of W. And because the value of W depends upon Z, therefore first of all, let us see the value of Z which will satisfy this equation. This means mod of Z minus I is equal to mod of Z minus 3I. That is, Z is a complex number whose distance from minus I and 3I is equal. That is, minus I is somewhere here, 3I is somewhere here, and I is somewhere here. For this condition to be satisfied, Z should be anywhere on this line. I is the midpoint of 3I and minus I because this line is the perpendicular bisector of the line joining A and B. For any point on the perpendicular bisector, say P, PA and PB will be always equal, where the complex number of the point P is Z. That is, I mean to say, to satisfy this condition, Z should move anywhere on this line. If Z moves anywhere on this line, it surely means that the imaginary part of Z will be always 1. That is, the value of Z will be always in the form of X plus I, where X is this length. That is, we get the conclusion that this condition will be satisfied when Z is in the form of X plus I, where X is any real number. And now let us put this value of Z here. We get W is equal to ZZ bar, that is mod of X plus I square minus 2Z, that is X plus I plus 2. I have put the value of Z in this equation. That is, I get W is equal to X square plus 1 minus 2x plus 2 minus 2i. That is w is equal to x minus 1 whole square plus 2 minus 2i. It is clear that the real part of w will become minimum when x is 1, and when x is 1 w becomes 2 minus 2i. Hence the value of w is 2 into 1 minus I, and you have to find the minimum value of n so that w to the power n is real. And I have told many times in many lectures that it is very useful to know that 1 plus I to the power 2 is 2i and 1 minus I to the power 2 is minus 2i. This is very useful concept to remember. Now omega to the power n becomes 2 into 1 minus I whole to the power 2 to the power n into 1 minus I to the power 2 whole to the power n by 2. This is equal to 2 to the power n into minus 2i to the power n by 2, and clearly this will become real if n by 2 is in the form of 2, 4, 6, etc. But we wanted the minimum value of n so that w to the power n is real. Hence clearly the minimum value of n so that it becomes real is when n by 2 is equal to 2, that is n is equal to 4. In this question he is saying the least value of mod z where z is a complex number which satisfies the inequality this is equal to. First thing which you should know is a to the power log of anything to the base a, that is if these two are same, answer is simply b, and this thing I am going to use here. This means e to the power mod z plus 3 into mod z minus 1 upon mod z plus 1 whole mod into log of 2 to the base e is greater than equal to log of the value of this is under root 175 plus 81 base root 2. This implies that now this whole will go in the power of 2 and will be getting e to the power log of 2 to the power mod z plus 3 into mod z minus 1 upon this outside mod is of no value, it is simply mod z plus 1 because inside portion is already positive, is greater than equal to log of 16 to the base root 2. This implies that 2 to the power mod z plus 3 into mod z minus 1 upon mod z plus 1 is greater than equal to 4 upon 1 by 2 log 2 to the base 2. This implies that 2 to the power mod z plus 3 into mod z minus 1 upon mod z plus 1 is greater than equal to, it is 1, it is 8. That is I can say mod z plus 3 into mod z minus 1 upon mod z plus 1 is greater than equal to 3, which implies that mod z plus 3 into mod z minus 1 greater than equal to 3 into mod z plus 3, that is mod z square plus 2 into mod z minus 3 is greater than equal to 3 mod z plus 3, that is I get mod z square minus mod z minus 6 greater than equal to 0. This means mod z minus 3 into mod z plus 2 greater than equal to 0, which means mod z minus 3 is greater than equal to 0, which implies that the mod z is greater than equal to 3. Hence I can say least value of mod z is 3. Therefore C becomes a correct choice. In this question, it is given to us that let z be those complex numbers which satisfy mod of z plus 5 less than equal to 4, and this condition, if the maximum value of mod of z plus 1 whole square is alpha plus beta root 2, then the value of alpha plus beta is. Before I do this question, first I will tell you a concept that in complex number, equation of line is in the form of az bar plus a bar z plus b equal to 0, where b is real. And if some equation of line in complex number is given to you and you have to find the points where the line cuts x-axis, that is real axis, and the points where the line cuts y-axis, that is imaginary axis, the procedure is to find the points where the line cuts x-axis. For finding that point, for z bar, write z and get the value of z. That is z will be equal to minus b upon a plus a bar. That is for finding the point where the line has cut x-axis. For that, for z bar, write z, and the value of z you will be getting will be the x coordinate of the point where the line cuts x-axis, or you can say real axis. To find the point where the line cuts y-axis, for z bar, write minus z. Actually, I am using this because for this point z bar and z will be same, and for this point z bar will be equal to minus z. That is why if you want to find this point, put minus z for z bar, and the value of z you will be getting will be the y coordinate of this point. That is, here if I write minus z for z bar, I will get minus a plus a bar into z plus b equal to 0, and the value of z will be b upon a minus a bar. This is the y coordinate of the point where the line cuts y-axis. You must know these steps. We also know that the equation mod of z minus z0 equal to r represent a circle with apex of center z0 and radius r. And if it is less than equal to r, then it will be representing all the points inside also and boundary also with apex of center z0 and radius r. All these things you must be knowing. And now let us draw the diagram. Mod of z plus 5 less than equal to 4 means z will lie anywhere on the circle or inside the circle with apex of center minus 5 and radius 4, because it is less than equal to 4 is given to you. And This can be written as z into 1 plus I plus z bar into plus 10 greater than equal to 0. First thing, z into equal to 0 represent a line, and to find the points where the line cuts x-axis and y-axis, for z bar write z and the value of z will be the point where the line cuts x-axis. If I write z for z bar, I will get 2z plus 10 equal 0. That is z equal to minus 5. That is, this will be the point where the line will cut x-axis, that is real axis. And for finding the point where the line cuts y-axis, that is imaginary axis, for z bar write minus z. For z bar, if I write minus z, then I will get z into 1 plus I minus plus 10 equal 0. That is z equal to minus 10 upon 2i, that is 5i. That is, this is a point where the line cuts y-axis. That is, this equation represent this line. And because if I want to draw the graph of this, then shading will also be there. For this, only one line will be there. But for this, shading will also be there. To check on which side shading will be there, let us take the example of origin. By writing z equal 0, I am getting 10. 10 greater than equal 0 is true. Therefore, I will say shading will be on this side. And according to this, shading should be on this side of line. According to that, shading should be inside this circle. That is, common shaded portion will be this is a common shaded portion. Mod of z plus 1 means z minus this thing. Z lies anywhere on this circle. Minus is somewhere here because radius is 4. And clearly out of all these points, this point is at maximum distance from this point. And from here 5 and 5, we can easily say that the angle is 45 degree. Hence this angle is 45 degree. Therefore, using the concept of parametric equation of circle, I can say x coordinate of this point will be minus 5 minus 4 cos 45. That is, x is minus 5 minus 2 root 2. And the value of y will be minus 4 sine 45, that is minus 2 root 2. Hence, for this point, x coordinate is this, y coordinate is this. Let us name this point as A, this point as B. Out of all these points, this point is at maximum distance from the point A. Now, AB is equal to minus 5 minus 2 root 2 minus 1 whole square plus minus 2 root 2 whole square. 4 plus 2 root 2 whole square plus 8. Hence, mod of z plus 1 square means ab square equal to 4 plus 2 root 2 whole square plus 8.